All right, today's lesson is quite straightforward. We're simply going to change our notation a little bit. So far we've been using the following notation for sequences. We use this a lot: A sub n, right? So when we say something like A sub 5, that means the fifth number, right? If we say A sub 10, that means the 10th number in the sequence, right? It's kind of like that's your input. Okay, so because that number actually is the input, we can actually write these in function notation. So for example, yesterday we were seeing we'll start with an arithmetic recursive rule. We could have seen a recursive rule that said A sub n equals A sub n minus 1 plus, let's say, plus 5. And then you had to state, well, A sub 1 equals, I'm peeking right here, 9. Okay, and that meant that the function's first term is 9, or the sequence first term is 9, and your common difference is 5. So start at 9 and add 5 each time. So you go 9, 14, and then add 5 again, and you get 19. All right, and then continue adding 5. Well, this is no different. So take a look at this bad boy right here, okay? Very similar. So in this case, it says f of 1 is 9. In other words, if my input is 1, my output is 9, meaning the first term is 9, right? F of 1 is the same as saying a sub 1. And then it says f of n equals f of n minus 1 plus 5. So f of n minus 1 still means previous term. It means a sub n minus 1 plus 5. That means that if I wanted to find f of 6, right, well, I would have to know the fifth term, because f of 6 is going to be equal to the previous term, which is going to be f of 5 plus 5. Whatever the fifth term is, you add 5. This again shows you recursive formulas are really only good to find the very next term. For example, to know the next term after 19, I add 5, and then I add 5, then I add 5. If I want to find a term way down the line, like the 32nd term, I would be better off using an explicit formula. So that is basically the only new thing. You're changing a sub n for f of n, and nothing else is different. Okay, we can do this also with a geometric example. Remember, geometric is exponential. And with the geometric example, I have f of 1 equals 2, f of n equals negative 5 times f of n minus 1. All right, in other words, start, I always say start, but first term is 2. Common ratio is negative 5, so multiply by negative 5 each time. So 2 times negative 5 is negative 10. Negative 10 times negative 5 is 50, and 50 times negative 5 is negative 250, et cetera, et cetera, et cetera. So that is how you write recursive formulas using function notation.